all CEOs, me included, we don't actually know what we're doing.
They're all sharks, so all you got to do, though, is know shark behavior.
I don't think we've ever talked about this before, guys.
We can capture all of the wallet share.
First place you start is with the product.
That's just the first nut.
This is the Capital Stack. Hey everybody, this is David Paul, the host of the Capital Stack podcast, where I talk to founders, operators, and investors about all things value creation within startups. Today, I've got another celebrity. I guess I'm getting a little bit better at this because I'm getting higher caliber people. And I think that people are starting to listen to this, so I'm extremely happy. Today, I've got Vivas Kumar, who is the founder and CEO of Mitra Chem, which is a deep tech battery manufacturing company. Did I get that right?
Yeah,
Vivas?
Well, I'm wondering who's the celebrity?
You're the celebrity. Come on, don't be modest. Don't be modest. But Vivas is the CEO. He was a huge, big-time executive at Tesla, where you worked in the battery division, and came off and are starting to do, charging technology within EVs as well as, home-based charging units. Tell me what Mitra Chem's doing, Vivas, and tell me a little bit about yourself.
Well, thanks for having me on. Mitra Chem does three things. The first is speed, using an in-house AI advantage to significantly reduce the time to bring battery materials products from lab to market. The second is a focus on iron-based battery materials, which are safer, cheaper, and originate from cleaner supply chains than today's Western nickel-rich standard. And then the final is to build manufacturing scale along with partners here in the USA to offset our geopolitical dependence on companies operating in China, which is a huge Achilles heel for many industrial supply chains, even beyond the battery supply chain.
Yeah, no, it's a really big deal. I was talking to one of the main product people at Harbor Freight, and they've just, they make shitty tools, right? And like, he was an OEM, and he said that his board directive stated that he needed to bring 25% of his supply chain to North America within a year.
Absolutely. I mean, it's a directive that's happening from companies. It's a directive that's also happening from government. A big tailwind for my business is the Inflation Reduction Act, which has set up all sorts of subsidies and tax breaks, both for the production and the consumption of multiple materials in electrification and decarbonization supply chains. So a push towards more nearshoring in the United States is something that is beneficial for multiple different industries, and certainly my company is standing at the forefront of battery materials.
So we're basically talking about a battery technology that doesn't need lithium or I would guess nickel and lithium, which is primarily a precious metal that's found in these areas that we are having conflicts with, and that we can actually mine and supply and create batteries within our own soil. Is that kind of correct?
So the way to think about this, let's simplify what a battery is. You have a cathode, you have an anode. One is a plus, one is a minus. A lithium atom from the cathode becomes ionized, releases electrons, and the flow of electrons is the electricity that's discharged from the battery. So that's a very battery 101 explanation. I'm sure those of you who are physicists out there can critique this and go 5 or 6 levels deeper, but roll with it.
I still don't get what you just said, but keep going. No, I'm just kidding. You're like, I can't dumb this down anymore, David. But
well, I mean, if I were to think about it this way, every single one of you has interacted with a smartphone at this point. If you remember what TV remote batteries look like, you would just pop an Energizer in there, right? Mm-hmm. Or if you had the RC cars, you would pop those batteries. So one side is a plus, one side is a minus, right? One side is the cathode, one side is the anode. And the cathodes are the most expensive part of the battery, and they also dictate the performance of the entire battery cell. And so we are working on iron-rich cathode materials. In the West, for electric vehicles, nickel-rich cathodes have been the industry standard. However, we're seeing a transition happening towards iron-rich, which has been the standard for almost 20 years now in China. And they're increasingly becoming the standard in the West because they're safer, they're cheaper, and the supply chains are easier to source here in the West as well.
So why wasn't it like that from the beginning?
It wasn't like that from the beginning because energy density is higher from nickel-rich cathodes. And what does that mean for you as the customer? That means with a pack that has nickel-rich battery materials, you could drive your car further. For a long time, range anxiety was an issue for electric vehicles. What we're transitioning to now, though, is iron-rich cathodes. There's a whole portfolio of products that we're going after that are starting to improve significantly when it comes to energy density, and at the pack level start to rival nickel-rich battery packs. And so that's why the time is now for this kind of portfolio to take over in the West, in the markets where we're serving.
So the technology is basically catching up where we can use raw materials that are more clean, cheap, and accessible for the United States.
That's exactly right.
Amazing. And did this IP come out of Stanford, where you did a lot of your studying? Was this something that you guys developed internally within your R&D?
Well, I'm very fortunate that one of my co-founders is still a professor in the engineering school at Stanford. His name is Professor Will Chu from the Materials Science Department. Much of his work in the last 10 years has focused on battery materials, but he is focused on other research topics as compared to the iron-rich cathode thesis that we're going after. The big thing that he worked on at Stanford that inspired the journey of this company was that first part of our thesis that I mentioned, the speed. Using the same principles of accelerated drug discovery and applying it to a different chemistry search space, which for us is battery materials.
Okay, that's amazing. And so when you think about kind of the adoption of EV kind of batteries within the home, solar, how much of that is, I would say, commercially demand driven versus, kind of just government subsidy driven, fad driven? When do you think the inflection point is when, people are just like, oh no, this is like without a doubt 100% more effective for me to be using solar / battery / other types of utilities that might be coal or oil generated?
It's a bit of chicken and the egg because you could argue that what's happening today with government subsidies around the production and consumption of various decarbonization technologies is as a result of these technologies being cheaper and also being, how do you say this, in vogue or in fashion with consumers. But the reality is they became cheaper because of government investments over time. Right? And so for any platform technology to take hold, the government, DARPA, DOE, are usually the first major investors to bring the cost curve down and to bring the technology readiness up before technology can get to prime time.
Yeah, that's when it's more of a science experiment.
Absolutely. It's more of a science experiment.
Got it. And so right now, is energy going to zero?
Is energy going to zero? Well, energy costs have relentlessly been on a march to 0 cents per kilowatt hours since the beginning of time. Mm-hmm. Every great society has been built on having access to cheaper and cheaper energy. And the relentless march towards zero is what has pushed us towards innovating in electrification. You mentioned solar and storage. I mean, we're getting to a point where some parts of the world are seeing solar costs be less than 2 US cents per kilowatt hour, right? That's an unimaginably low price. And the cheaper and cheaper energy you get, the more and more you can manufacture, and the more and more prosperous a society you can build off of manufactured goods.
And so how much is the adoption stifled just by regulatory capture within kind of big oil, lobbyists, special interests, et cetera? I would think that would be kind of the biggest barrier to really widespread adoption.
That is a big barrier, but the reality is the best products and the best science do win over time. Mm-hmm. And if I can jump off of one point that you made, which is oil companies, I actually very strongly believe that oil companies have a role to play in this in a positive way. I am a clean energy entrepreneur myself, but I also respect that what oil companies bring is a global mandate and lots of experience in deploying large capital projects and in dealing with governments to get those projects deployed and built for the good of their citizens. And so when we talk about the proliferation of lots of these new technologies, oil companies are one of many types of actors that we could rely on to help us get there. So while you mention them as being special interests, right, I actually see them as all being part of a broader ecosystem.
I mean, that is a real affable way to look at it. Do you think they look at you the same way?
I think when these companies look at me, they see me as, and when I say me, I'm talking about Mitra Chem, they see our company as a very spirited and motivated, innovative technology company working at the forefront of material science to bring new products out to market that are very relevant to a fast-growing segment of the energy market.
That's a good place to be. That's good marketing positioning. I'd say so. So when you take a look at the products that you're bringing to market, where is Mitra Chem right now? Are you commercialized? Are you pushing stuff out? Like, what does the SKU count look like?
Yep, where we are today. So we're recording this podcast in mid-June 2023, and there's 3 products that we have in our portfolio today. The first is LFP, lithium iron phosphate, which is a well-industrialized cathode product that has been used in Chinese vehicles for over 20 years and is increasingly being used in US vehicles as well. The second is LMFP, lithium manganese iron phosphate, which is a product that is about 10% higher energy density than LFP and is more applicable to what consumers in the US want for their mass market EVs. Mm-hmm. And the final product is something that we call LMX. Now, we're not talking too much publicly about this product yet, but what I can tell you is that it will be able to rival the performance of nickel-rich at the pack level at a lower cost and less price volatility than nickel-rich cathodes. And we've already got plenty of customer conversations ongoing for all 3 products. And stay tuned because we've got, around the time that I think this podcast will release, we'll have some really big news to share on the customer front as well.
And so how long does it take to get commercialized within these OEMs? Because I'm sure, there's pilots, they've got, it's a risk taking on a technology such as yours. So how does one get implemented and put into that supply chain? And how do you think about that from a business perspective?
This is a great question because simply making the best technology, either at the lab scale or even at large scale, is not enough. Automotives will put you through a rigorous qualification process before your material is accepted within their supply chain. And what they want to know is, does your material perform? And can you reliably make this at scale in a sustainable fashion so that you will never become the supply chain bottleneck for them? So think about it this way. My previous employer, Tesla, we talked about how there were thousands of parts to make each individual vehicle. If even one part was missing, you can't make the vehicle. Mm-hmm. Now, the parts can go missing because of factors that you can control, like your inventory, or they can go missing because of factors that you rely on your suppliers for, which is continuous operation at a high ethical and professional standard of the business and of a high safety and scientific quality standard of the product itself. So when an automotive does qualification, that's what they're looking for. Can this company reliably and replicably produce this product at scale to meet the specification for me? This is a process that lasts many years. The best way in which to get qualified is to start a technology partnership very early in your development cycle as a company. And this is exactly the approach that we've taken even with our initial customer work. It's been sending samples to enable us to showcase our capability to make an industry relevant and applicable product so that we'll be prioritized for qualification. Knowing that once we begin this type of technology partnership, it will take 2 or 3 years for our product to be ready to be in their supply chains, but that by the time we get there, we will know each other so well as companies that we'll be able to collaboratively problem solve towards the outcome that we want, which is for our product to be in the vehicle and for their vehicles to be on the road to generate cash flow for all of us.
Is there a capital strategy where they can kind of co-invest and be along for the ride, or is that just kind of an IP you don't want them in the hen house, so to speak.
There's many different approaches that you can take towards the downstream customers in an industry like ours. And what we find is, of the product suite that we have, we believe that we are in a very good position to innovate towards the outcomes that are customer driven because of our in-house acceleration advantage. When it comes to our LMX product, for example, we own all of the IP on that product, and we'll continue to focus on owning the IP on that product because it's relevant for multiple different customers and not just one. However, what we need guidance on is how to get qualified. What are the steps? How will our product be integrated into their roadmap? We're making battery materials. We need to be accepted by a battery cell maker in order to be accepted into the vehicle as well. So there's all these different parts in the supply chain that we ourselves are not able to put together, that the downstream customers are able to put together for us.
And so what was your interest, Vivas, in going into kind of clean tech technology, going through Stanford, working at Tesla? What was the origin story with this?
My background is that I grew up in Singapore and in Houston, Texas, which are two cities that are very famous for the oil and gas industry. That's where my folks worked for 40 plus years within the industry. And it enabled them to live an incredible life. But they advised me when I was coming out of university at Rice University in Houston that the best opportunities were no longer probably going to be in the oil and gas industry as the world reached peak oil and as renewables were starting to take off. So they pushed me towards, greener pastures, literally and figuratively. And when I left Houston to move to Silicon Valley, Tesla's the first job I got within the space, and then it was off to the races. I had a wonderful opportunity to work with the team. Will Drury, who's another former guest of yours on this podcast, was a manager that I worked very closely with. Had a lot of exposure to Elon, had a lot of exposure to the Model 3 program, which at the time was the flagship program for the company, and got to do business in 40 different countries, sourcing the battery supply chain for Tesla. So it was a trial by fire, and got to learn about this industry, the battery supply chain, where I'm building my own company now today as well.
So you knew nothing of batteries before you went into Tesla?
Well, I was an electrical engineer, so I knew the basics.
Okay,
But, it was a trial by fire, right? Everything at Tesla was a trial by fire because Tesla very much functioned like an early stage company at that time. And even today in my company, Mitra Chem, everything here is trial by fire in a very positive way. I mean, we're building the company and building the processes and systems as we go along. And when it comes to, learning how to manage people or learning how to manage projects or learning how to make batteries work, all of that was trial by fire. And here I am, this is my 8th year in the battery industry. I came in knowing absolutely nothing, and now I'm building a company in the space. So anybody who's motivated to want to get into renewables or get into batteries, just find your first opportunity. And, those of us who've been here for a while, and I'll tell you, 8 years is kind of a while when you think about the growth trajectory of this industry, where we were back then versus where we are now. We're very open-minded to new people joining the industry because we know that we need the best talent coming into the industry to build batteries for all the vehicles that we put out in the world.
So aside from startup mentality, trial by fire, what are some of the values or ethos that you have pulled from Tesla vis-a-vis Elon culture that is transferable probably into a company that's a material science company? It's not a typical business-to-business SaaS company where 95% of investors invest, but it's something that's more frontier, it's longer, you need more patient investors. How do you think about kind of building a company from that construct?
I think you hit the nail on the head just with those words that you said. It's more longer, it's more patient. I mentioned having worked on the Model 3 program, and Model 3 is now one of the best-selling vehicles in the world 5 years after its launch. Actually 6 years after its launch. However, Tesla as a company had existed for 15 years by the time the Model 3 had launched as the flagship product. And so getting hard tech products out in the world at scale in a way that makes you become a category defining company, it's a very long process in this industry. I've noticed, because I have a lot of friends who are entrepreneurs in the SaaS space, there's a lot of emphasis on finding the right customers and then growing your customer footprint as quickly as possible in SaaS. And you can feel free to rebut me, David, because I know that you know the space a lot better. But for hard tech, the product development cycle makes it such that the emphasis on sales comes much later in the life cycle. And so for the first many years, it is all about figuring out what the customer wants and spending lots of iterations and lots of time to build that product. And it'll be years before your flagship product to become a truly category-defining company comes out to the market. But I'm here to play that game. I mean, I'm operating in a space where we're creating technologies to solve climate change, which is a generation-defining problem. So the outcome and the success that we achieve in this company will not be something that's articulated in a 2 to 5 year span. Right? It's something that will be articulated in a 20 to 30 year span.
Is that why you decided to take family office money at Social Capital?
We've had a wonderful relationship with Social Capital from the very beginning of this company. Chamath Palihapitya, who is, of course, the CEO of Social Capital, and I got to know each other even before I started this company. And I was telling him about some of the ideas I have for the battery supply chain. And he very generously offered the opportunity for us to start the company from his office, led our initial funding round. And what I appreciated about Chamath is exactly what you said, which is extremely patient capital. He told me from the very beginning that he's made hardware bets for years, and he doesn't have expectations of a quarterly return or a 1 year return on that investment, and that he was ready to play the game of this being a 10-year journey. And I appreciated that very much because I had seen the development cycle needed to bring a product like this out to market with the Model 3. And here we are 2.5 years into our company journey, and not once has he asked me about, what's your exit, what's your multiple, what's your valuation, et cetera. The only questions that he has asked are, what does the customer want? What product are you building to meet that customer need? And going beyond Chamath, I mean, we have a stable of incredible investors from around the world, over a dozen institutional investors, and many of whom self-selected into working with us in this company because they feel the same way. They feel that climate change is a pressing generational issue, that they cannot be measuring the success of their investment in this company in a 2 to 3 to 5 year time horizon. And they are here for that journey as well.
Yeah, no, absolutely. I always feel that, because I follow Social Capital's works, and of course, with that I follow Chamath and how he thinks about things. I mean, he's just, I just feel like he's so, not just intellectually, but emotionally attuned to like the investments that he's making, right? And the founders that he's backing. It's really fascinating. And the questions he asks, it's pretty mind blowing. It's pretty cool you were able to incubate out of his office. So what's the next step? What's the next 3 to 5 years look like for you?
Well, the number one goal that I have is to get a product into the hands of an electric vehicle manufacturer, into their vehicles on the road to generate cash flow. That is the goal for the next 5 years. Single-minded focus towards that goal.
And, to do that, how, obviously you've got some tailwinds with infrastructure bills. We talked earlier about these kind of government subsidies being necessary for early stage innovation. Was this something that you felt like when you were starting the company that, there was just going to be more investment on the government side from an infrastructure? Was this a pleasant surprise? How'd you think about it?
When we started the company, the Inflation Reduction Act was still over 1.5 years away. However, we knew that it was something of that ilk was probably on the horizon. I had a chance in my previous life to spend a lot of time in Washington, D.C. And I was very lucky that a couple of my investors also had spent a lot of time in terms of policy education in D.C. And they were telling me, the writing's on the wall that government at the federal level wants to do something really big on climate. We just don't know what the timeline to get there will be. So when I started the company, it was not started with a regulatory tailwind, but it was with the hope that regulatory would give us a tailwind in the future. We started the company because we cared about solving climate change. We thought that batteries were a platform technology to help solve climate change, and that we thought we had a unique edge in how to make batteries better.
Got it. Cool. Vivas, thank you so much for coming on. I really appreciate it. A couple canned questions, if you don't mind, before we end. What is your favorite book?
My favorite book is Nelson Mandela's biography. And the reason is because you want to talk about ultra long-term thinking, right? That book is the definition of ultra long-term thinking.
Okay. Right on. And then best piece of business advice you've ever gotten?
Best piece of business advice is sleep 8 hours a night.
That's good.
As a CEO, my job is to make really high-quality decisions that impact many, many lives within and outside the company. The best service I can do to everybody is make sure that I'm clear-headed when I'm making those decisions. And it starts with sleeping 8 hours a night.
Do you like being a founder?
This is the job that I was born to do. I will say it's not an easy job. I definitely didn't realize some of the complications that came with it, but I can't imagine my life not being a founder anymore now that I've done it.
Yeah. There's no way you're taking a job ever again, even if you do sell this thing.
I don't even know what that would be like for me anymore now that I've tasted the thrill of victory on this side.
Yeah. It's a roller coaster, that's for sure. Thank you, everybody, so much for tuning in. If you like what you heard, please subscribe, tell a friend, leave a comment, and we will see you next week. Thank you. Bye-bye.
Thank you for tuning in to the Capital Stack Podcast. Make sure to share this with someone you know that can benefit from this content. Remember to support this show by rating, reviewing, and subscribing. David Paul is the founder and general partner at DWP Capital. All opinions expressed by David and podcast guests are solely their own opinions and do not reflect the opinion of DWP Capital. This podcast is for informational purposes only and should not be relied upon for decisions. David and guests may maintain positions in the securities discussed on this podcast.